You guys remember where you were January 28, 1986? January 28th. Right, a few of you weren't born.
Oh, that was me.
Huh? Anyone? All right, I'll give you a clue. I'm going to date myself here too. Does this help? Yep. Okay, so I was in the 8th grade. I lived in Jacksonville, Florida. And my class actually took a field trip to Cape Canaveral 6 days before this picture was taken. We even took a bus ride out by Launch Pad 39B, which is where the Challenger was already sitting out there. Then 6 days later, I remember where I was when it launched, and 72 seconds after liftoff, it exploded. From the very next morning, this is the New York Times paper, from the very next morning, there were concerns that the O-rings had contributed to the disaster, and that they actually leaked, caused fuel to leak, and that's why it exploded. Actually, I take that back. There were concerns before it was even launched that the O-rings might leak. The engineers from the company that makes the solid rocket boosters, Martin Thiokol, they'd actually identified a pattern. They looked at all the previous shuttle launches, and they'd seen that at colder temperatures, the O-rings would leak. So there was an internal meeting at NASA the night before the launch. Martin Thiokol engineers, the reports are this was a heated meeting. They were fist pounding on tables, launched the shuttle. They showed 2 overhead slides, transparencies. This is one of them, and then this is the other. So this is their data. This was their argument to the decision makers at NASA. Don't launch the shuttle, because as you can clearly see here, at colder temperatures, the O-rings leak. You guys see that? Right, exactly. Zoe and I have looked at it all weekend, and neither did the decision makers at NASA, or they wouldn't have launched the shuttle, right? So there's a fella, actually I have this book over here, I've had it for a few years. His name's Edward Tufte. Interestingly, he's from Kansas City. He's also a computer science professor at Yale and a pioneer in how we visually represent data. In this book, he reformats those same 2 overhead transparencies into this one slide. So what you're looking at here across the horizontal axis are the temperatures at all the previous launches. The red dots are the previous shuttle launches. And then the vertical axis are the number of O-rings that failed at each one of the launches. So if you extrapolate the damage curve all the way up to the temperature on January 28, 1986, I mean, a child can see that, right? It doesn't take a rocket scientist to see that that's outside of the range of safety and certainly cause for concern. So it's not, the O-rings didn't send the astronauts into space that cold morning, right? People did. Right? And it's not bad slides that kill people, it's bad decisions. Right? And the reason we start out with this is because I personally feel that just as in NASA and rocket science, that in healthcare, we're making decisions where lives are on the line every day. And it's really about having not just the information at your fingertips, but it's about how it's displayed and does it tell a story. And in our case, it's does it tell a patient's story. So we'd like to welcome you, A, to welcome you to Kansas City, and B, welcome you here to Cerner. My name is Holland Haney. I'm a physician executive here at Cerner.